Hey there, and welcome. Today, we are going to tackle a core concept in math, functions. Now, if that word makes you kind of nervous, don't sweat it. By the end of this, I promise you'll see functions not as some big mystery, but as a simple, powerful tool you can absolutely master. Look, if terms like f of x, antecedent, or image have ever made your head spin, you are definitely not alone. It's kind of like learning a new language, right? Well, today, we're going to become fluent together.
So let's just push all the complicated formulas aside for a second. What if we thought about a function as something much, much simpler? Like a machine. You know, a machine that takes something in, follows one single rule, and gives you a predictable result. Every single time.
And this is going to be our secret weapon today, the function machine. Using this one simple idea, we're going to break down exactly how functions work, piece by piece, until it all just clicks.
Every single function machine has just three simple parts. First, there's the input. That's just the number you start with. Second, you've got the rule. That's the specific job the machine does, like maybe its job is to add 3. And third, you get the output, the one single predictable result that comes out. Input, rule, output. That's the whole shebang.
Now, I know you're working in the French system, so you're going to see some different words, but don't let them throw you off. They mean the exact same thing. When you see antécédents, just think input. And when you see image, just think output. They're just different labels for the very same parts of our machine.
All right, enough theory. Let's fire this machine up and get our hands dirty. We're going to start putting some numbers in and see what actually comes out the other side. Okay, so let's give our machine its first rule. You'll see it written down like this. F of x equals x plus 3. Now, don't let that f of x part scare you. That's just a fancy name for this particular machine. The part we really care about is the rule, x plus 3. All it means is that whatever number we put in for x, this machine's only job is to add 3 to it. Simple as that.
So let's try it out. We take the number 4 and we pop it into our add 3 machine. What do you think is going to come out the other side?
You got it. The input, our antecedent, is 4. The machine does its one job. It applies the rule, add 3, and out comes the output, our image, which is 7. It's totally predictable. It will do this every single time you put a 4 in.
And you know what the best part is? This exact same process, input, rule, output, works for any rule you can think of. If the machine's rule is multiply by 2 and we put in a 7, we get 14. If the rule is square the number and we put in a 5, we get 25. The logic never, ever changes. Okay, so we know how to get one output from one input. That's awesome. But what about the function's overall behavior? How do we know its general direction without having to test every number in the universe? Well, for that, we need to look at the machine's blueprint.
This blueprint is called a variation table, or tableau de variation. Yeah, it sounds super fancy, but it's just a really simple chart that gives us a quick summary. It tells us just one thing. As our inputs get bigger, are the outputs also getting bigger, or are they getting smaller?
And for the simplest kind of functions, the ones that make straight lines, it gets even easier. You've probably seen them written like y equals ax plus b. All you need to care about right now is that number a, the number right next to the x. It's called the slope, and it controls the entire direction of the function. And check this out. There are only 3 simple rules to know. If that a number is positive, the function is always increasing. It's going up. If a is negative, the function is always decreasing. It's going down. And if a is 0, well, it's not changing at all. It's just flat or constant. Okay, let's test this out. We've got the function f of x equals 2x minus 1. So the number in that a spot, our slope, is 2. And since 2 is a positive number, what does our new rule tell us about the function's direction? Exactly, it's increasing. And in our variation table, our blueprint, we show that with just a simple upward arrow. That's literally it. This one little arrow summarizes the entire behavior of that function. Let's do one more. F of x equals negative 3x plus 4. Okay, what's our a value this time? It's negative 3. And since a is negative, our rule says the function has to be what? Decreasing. You got it. So in our blueprint, we just draw a down arrow. This tells us, at a glance, that for this machine, as our inputs get bigger, our outputs will always get smaller. So we have our blueprint, the variation table. Now for the really cool part. Let's connect that abstract little plan to what it actually looks like in the real world, the graph of the function. And here is the single biggest takeaway for this whole section. The blueprint and the final building always match.
The story that the table tells you with its arrows is the exact same story the graph shows you with its line.
And the connection is so direct it's almost funny. An up arrow in your table, that literally becomes a line that goes up from left to right on the graph. A down arrow in the table, well, that means the line on the graph slopes down. It's a perfect visual match.
All right, let's just pause for a second and take a look at what we've done. You haven't just memorized a couple of rules. You've actually built yourself a powerful new toolkit that's going to help you understand pretty much any function that comes your way.
So think about it. You now know that a function is just a simple machine. You know that an antecedent goes in and an image comes out. You know that those variation tables are just blueprints for the function's direction. And you know that the arrow in that blueprint tells you exactly what the final graph is going to look like. You have seriously gone from mystery to mastery.
You have built the perfect foundation. You now have the tools and, more importantly, the confidence to take the next step and see how these exact same ideas apply to even more interesting functions. You are so ready for this. You've got this.